Introduction. In the Makassar Strait, studies have shown a mean southward flow, which accounts for 80% of the Indonesian throughflow from the Pacific to the Indian Ocean. The seasonal variations are significant, and well correlated with seasonal sea level differences between islands in the Pacific Ocean and the Indian Ocean. In the boreal summer, the seasonal sea level anomaly is lower in the Indian Ocean and higher in the Pacific Ocean, and the southward current in the Makassar Strait becomes stronger. But are these seasonal surface velocity variations in the Makassar Strait caused by the pressure gradient between the two oceans? Methods. We investigated seasonal sea surface height variations in and around the Makassar Strait, using 17 years of Jason series satellite altimeter data. We used ungridded along-track data, since spatial interpolations in the mapping process may produce pseudo-signals in areas of such complex topography. After separating variations shorter than 300 days and longer than 390 days, mean seasonal variations are determined at each along-track point. Results and discussion. Seasonal sea surface height variations in the Makassar Strait, marked by M, show similar variations to the Indian Ocean. The amplitude is slightly smaller, but could be consistent if the sea level difference between the two oceans penetrates the Makassar Strait. However, seasonal variations at the other points behave significantly differently. Both variations at a point north of Lombok Strait in the Java Sea that is marked by L, and at a point in the Celebes Sea marked by C, are not correlated with known variations. Namely, the signature of the sea level difference between the two oceans is not recognized in the Celebes Sea or the Java Sea. In addition, seasonal variations in the Indian Ocean are not the same at a coastal point south of Java Island, marked by J, and at an offshore point, marked I. Referring to the seasonal variations at the point M in the Makassar Strait, the correlation coefficient and the amplitude ratio of in-phase signals at each along-track point are indicated on the map by the color and the size of a circle. Significant positive correlations are found within the Makassar Strait, the northern part of the Java and Flores Seas, and even in the southern part of the Celebes Sea. However, the sizes of the circles are significantly smaller in the northern Makassar Strait and the Celebes Sea. As a result, a large sea surface height gradient would appear inside the Makassar Strait at around 3 degrees S, where the width of the strait deeper than 50 meters changes significantly. We also see significant positive correlations in the Indian Ocean, although these are located along the islands only. Meanwhile, significant negative correlations with blue colors are only found in the Pacific Ocean. Therefore, island sea levels in the Pacific and Indian Oceans are well correlated with variations in the Makassar Strait. However, variations in the Pacific and Indian Oceans are isolated from the ones in the Makassar Strait by uncorrelated areas in the Celebes Sea and in the southern part of the Flores and Java Seas. This suggests that sea level variations near islands in the two oceans coincide with variations in the Makassar Strait, but are independent. What drives seasonal velocity variations in the Makassar Strait? Balances between the terms in the equation of motion, namely the pressure gradient, the acceleration, wind stress, and bottom friction, are examined in the Makassar Strait. The wind stress and acceleration terms are too small to balance with the pressure gradient and bottom friction terms. Because the southern part of the Makassar Strait is shallower than 50 meters, the bottom friction is not negligible. Such large changes in the bottom topography would also produce changes in the sea surface height.